Hello everyone, welcome back to Bhanzu classes. My name is Ashdeep and I am here with a very interesting topic, that is algebraic expression. So let's get started everyone. So, discussing about algebraic expression, so we have already come across very simple algebraic expression terms like we have x plus 3, we have y minus 5, we have 4x plus 5, we have 10y minus 5, and so on. So, all this you have already understood in your previous classes. So basically, you might have seen how these expressions are also used in formulating the different puzzles and problems. So now coming up, expressions are very integral in algebra. So in this chapter, we'll be discussing about how expressions are formed, how they can be combined, and how we can find their values and how we can use it. So let's quickly get started with it. So, coming to the very first topic that we have is how expressions are formed. So, we need to understand that when it comes to algebraic expression, we have two important things. The first one is variable, and the second one is constant. Now, to understand how the variables are different from constant, variable is something which can take any value, or we can simply say that its value is not fixed. Let's suppose you went to the market and you brought 10 pens. Okay, and you do not know the price of each pen, right? So here we assume that the price of each pen is, let's suppose, y. So now we can simply say that here, y is variable. Variable, something which value is not fixed. On the other hand, we have constant where we can say that it has a fixed value. Let's suppose the price of each pen is rupees 15. So here 15 is nothing but it is constant, right? The value 15 will not change. But when it comes to variable, we can use any alphabet like we have X, Y, L, M. All these indicate as a variable. Now, to combine with both of them, so when the variables and constant combine, they make the algebraic expression. So to understand here with coming up to what exactly the algebraic expression. So when variables combine with constant, they combine by using operators. So we have different operations in mathematics. We have addition, we have subtraction, we have multiplication, we have division. When we use these operators along with the variables and constant, so they become the expression. For example, we have 4x plus 5. So 4x plus 5, what exactly is this? Here we have simply multiplied the variable x with 4, and then we have added a constant, that is 5. So here in total 4x plus 5 becomes an expression. Similarly, if we talk about another example, we have 10y minus 20. So first of all, we have the variable y. So now we multiply y by 10 and then subtract 20 from the product. So we got the expression. So this is simply how the algebraic expressions are formed. Now to understand about this, let's take an example. So here we have an example. Look at how the following expressions are obtained. So talking about the first one is simply x square, or we call it as x raised to the power 2, which you'll understand in the chapter exponent and power. So that's nothing but we have multiply x by itself. Like simply if you remember that 5 being multiplied by 5, we call it as 5 square. So simply x being multiplied by x is called as x square. So this is how this expression has been obtained. Now next example we have is 2y square. So here as we can see, 2y square is simply y square, that is y being multiplied by itself, and then we got y square, and then we multiplied this y square by 2 to get 2y square, right? Let's try another one. Now next one we have is 3x square minus 5. So 3x square minus 5. So how do we get it? We'll simply multiply x by x. So we got it as x square, and then we multiplied x square with 3. So we got 3x square, and then we simply subtracted 5 from its product. So we got the expression 3x square minus 5. Next one is quite easy. I hope you all have got the answers up till now. So xy is nothing but simply the product of x and y, right? The last one. So now I want you all to quickly think of the answer. So last we have is 4xy plus 7. So first of all, we'll multiply the variables x and y to get the product of x and y. And then we will multiply it by 4. So we got as 4xy. And then we simply add 7 to it to get the expression, that is 4xy plus 7. Now, in total, we understood how the expression is formed. But can you see up till the first and the second example, if we see the third one, we have 3x square and then we have minus 5. So what do we individually call them when we combine both of them? We know we have variables, we know we have constant, we have operations, and then the algebraic expression is formed. But what about these individual things that we have? So let's understand our very important and interesting thing about it, that is the terms of an expression. So simply we shall put that in a systematic form, what we have learned about how the expressions are formed. So for this purpose, we need to understand two important things. The first one is terms of an expression, and the second one is factors. So let's take an example over here. So here we can see we have the expression 4x plus 5. So simply how it will be formed, we'll multiply x with 4, we get 4x, and on the other hand, we add 5 to it. Now we have two separate things. We have 4x, we have 5, right? Another example, we have 3x square plus 7y. Again, here we have x square, which is x simply multiplied by x, and then we got multiplied by 3, we got 3x square, which is separately a product. On the other hand, 7y is a separate product, which is formed by simply multiplying 7 and y. Right. So here, these are nothing but they are called the terms. We have 3x square, we have 7y, which are separately being added. So they are nothing but they are the terms of an expression, right? So individually we call it as a term, and then when we combine this, we call it as an expression. Let me help you with this with the factor tree. Okay, let's understand more about it. Now, simply seeing to this factor tree, first of all, we have an example over here, that is 4x square minus 3y square. Now, to understand more about it, so simply if we see 4x square is separate and then minus 3xy is separate. Now, if I talk about 4x square, it is a term. On the other hand, minus 3xy is another term. But again, if we discuss about both of them individually, so we can see that 4x square is formed from the product of 4 x and x, right? So now individually when we further divide it, we call it as their factors. Like here, if I talk about minus 3xy, so we have three factors. We have minus 3, we have x, and we have y. So these become the factors. So on the simple note, we represent the terms and factors of the terms of an expressions and then the factors through a factor 3. factor tree. Okay. One thing to note over here is that we have used dotted lines. Here, can you see these dotted lines? These are indicated for the factors, and then we have continuous lines for the terms, so that we do not get confused between both of them, right? Now let's take one more example over here. So question would be asked by giving an expression, and then you have to show it, the terms and factor through a tree diagram. So simply if you see 5xy plus 10. So how do we get it? 5xy plus 10. So we have two terms over here. We have 5xy, we have 10. Both of them are separated by an operator, that is plus. So simply if we see further dividing 5xy, how is 5xy formed? It is formed from three factors, that is 5, x and y. So when we multiply 5x and y, we get 5xy. But on the other hand, 10 is constant. It does not have any other factor. We cannot further divide it, so we will leave it as it is. I hope you all are clear till here, right? So now moving further, we have a very important and last thing, that is coefficient. To understand with this, we have learned how to write a term as a product of factors. Now, one of those factors we saw can be a numerical, or other might contain the variables, like we saw in the last example. Here we had constant as well, and we also had a term which contains variable, right? So now coming up, the numerical factor is said to be numerical coefficient, or simply the coefficient of the term. Like the last expression, we have 5xy. Though 10 is constant, 10 does not have any variable. Now, when we have a numerical part along with the variable like 5xy, so now in front of this xy, we have 5. Now this numerical part, or what we call as coefficient of the term. So it is also said to be coefficient of the rest of the term. Like for example, in case we have 5xy. So 5 is the coefficient of the term, right? It is also the coefficient of xy as well. Now, in the term, if we talk about 10xyz, so 10 is the coefficient of the term, or we can say 10 is the coefficient of xyz, right? Simply, if we see another examples, like we have minus 7x square y square. So here minus 7 will become the coefficient of x square y square. Now, one thing to note here is that the sign also needs to take place. Okay, we have to take along negative or positive sign as well. Like we had minus 7, so we'll say it as minus 7 rather than saying that 7 is the coefficient of the term. Now, coming up to very important thing over here is that when it comes to coefficient, when the coefficient of a term is plus 1, we usually omit it. Okay, let's suppose if I talk about 1x, we do not write it as 1x, we simply write it as x. So here, as an whole, we can simply say that 1 is the coefficient of the term. Okay, so now simply if we have x square y square, so here also we do not have any numerical part, so it's obvious we will take 1 as its coefficient. But on the other hand, if we have the coefficient minus 1, it is indicated only by minus sign. Like let's suppose if we have minus 1x, so we simply write it as minus x. Similarly, if we have minus x square y square multiplied by minus 1, right? So we simply here write it as minus x square y square. And it's obvious here the coefficient would be minus 1. I hope you all are clear up till the basic things that we discussed. So now let's take a very simple example. Let's try this out. So what are the terms in the following expression and how the terms are formed? We have to draw a tree diagram. So we simply have the expression. Let's quickly try this out. X, Y. Let's try this question only. So we have 8y plus 3x square, right? So now simply if we go through the tree diagram, so now first of all, we need to tell the factors. So here we can see what are the, we need to simply tell the terms. So first of all, we have the terms. Simply here the terms would be 8y and then we have 3x square. Now, if we further divide the terms, what we will get? We will get the factors. So here we have 8 and y because 8y is formed from the product of 8 and y. And then we have 3x square which is nothing but 3 multiplied by x and x. So here you can see 8y and 3x square are the terms and then we have the factors. Okay. So the terms are indicated by a straight line and then we have factors indicated by dotted line. Are we clear up till here? All right. So this was it for today. So today we have basically discussed about three important things. First, how an expression is formed, wherein we saw we have two important things. We have variable, we have the constant, and then by the different operators that we have, we combine and then we get the algebraic expression. Then further, we discussed about the terms and factors. So simply when we talk about an algebraic expression, they are formed from the terms and further the terms are divided into different factors, right? And the last thing we discussed about the coefficients. So coefficients are nothing but they are the numerical part of the variable. Let's suppose we have 8xy. So 8 is the coefficient of the variable xy, or we can say of the term xy. I hope that's clear to everyone. So this was it for today. If you have any doubts, you can simply comment below. Thank you so much. So keep learning the Bhanzu way.